Okay, so on part A, what did this graph look like? It went through -2, 0. And what else did it go through? Oops. What else did it go through? 3, 0. And where was its vertex? It was really low, really high. Where was it? It was very high. Actually, I think it was at 12.5.5 actually. So way up here. So we had a, what is this called? Yeah, what transformation happened to this? It was translated up 12.5 and to the right 0.5. What else happened? It was vertically reflected. Okay. It's upside down. It was vertically reflected. It has, I think that it actually has a stretch of -2, or a vertical stretch of 2. Now, from this, it was clear the intercepts were at -2 and 3. So, how many solutions did it have? 2. And what were they? Perfect. X equals -2 and x equals 3. These are our solutions. What about the second graph? What did we notice about those solutions? How many solutions were there? Just one at 4, 0. Yeah. We had one solution at 4, 0. So x equals 4. And what about this one? How many solutions did we have here? Where was the vertex? 2, 5. Okay. Good. So, when the graph intercepts the x-axis twice, how many solutions do we have? When the graph intercepts the x-axis once, how many solutions? And when the graph doesn't intercept, how many real solutions do we have? Next class, we're going to learn about not real solutions or imaginary solutions. Yeah. Next class is imaginary solutions. Okay. So that's how you can find the solutions from the graph. Before we get into how to find the other solutions without using a graph, we need to review something. Do you remember simplifying radicals in geometry? You also kind of sort of should have done it in Algebra 1 as well. Who remembers simplifying radicals? Kind of? Oh my gosh. 3 people? All right. So this might be a struggle. When we are simplifying radicals, we are not asking you to put these into our calculator, right? I'm not asking you to put, square root of 125 in your calculator and give me a decimal. No. When I ask you to simplify radicals, what I want is whole numbers. I need this in simplest terms with whole numbers. No decimals here. So, what is the only square root or only radical that gives you a whole number when you square root it? Why does 25 give you a whole number? It's called a what? The only types of numbers that when you square root them give us a whole number is a perfect square. So essentially what we're trying to do here is pull out the perfect squares, because when we square root them, they give us whole numbers, and that's what we want here. So in this example up here, we split 40 into 4 and 10. Why did we do that? Because what is a perfect square? 4 is a perfect square, right? What is the square root of 4? 2. So now 2 square root 10, or 2 radical 10, is the radical in simplest terms. So does this make sense? You're looking for factors of the number that has a perfect square as a factor. So here, 2 factors of 40 are 4 and 10. Well, we split it into 4 and 10 because 4 was the biggest perfect square that goes into 40. So let's look at 125. What is a factor of 125 that is a perfect square? 25, right? Ooh, maybe it would be helpful to go over the perfect squares. Would that be helpful? What is 1 times 1? 1. So 1 is our smallest perfect square. What about 2 times 2? 4 is a perfect square. 3 times 3? What am I on? 4 times 4? 5 times 5? 6 times 6? 7 times 7? 8 times 8? 9 times 9? 10 times 10? 11 times 11? 12 times 12? 13 times 13? You're right, 169. What am I on? 14? 14. 196. 15. 225. Okay. I think that's good enough. Right around, I always forget 14 and I remember 15, and then from then on I can't remember. Does anyone know 16? I have no idea what 16 is. 256, you do on the calculator? Yeah. All right. So, which one of these is a factor of 125? 25, right? 25 is the biggest factor that is a perfect square that goes into 125. So, I can split this into 25. And what times 25 is 125? 5. So I can split it into 25 and 5. What is the square root of 25? 5. So 125 in simplest radical form is 5 square root 5. 5 radical 5. Is this starting to come back? What's another way you could have done this? Do you remember? You can create a factor tree. You could have created a factor tree here. Okay, what about 66? Yes, 2 factors that would multiply to get 66, one of them being a perfect square. Not both have to, yeah, both do not have to be perfect squares, just one of them. So the biggest perfect square that goes into 66 is 1. And what is the square root of 1? 1. So is this already in simplest radical form? Yeah. You can't simplify this anymore. This is it. What about the next one? What's a perfect square that goes into 64? It already is a perfect square, right? 8 times 8 is what? So 64 is a perfect square. So what is the square root of 64? 8. You just write 8.
Plus or minus 8?
Yeah, we'll get to that. So we made this paper last year when we had already covered imaginary numbers. We're covering imaginary numbers next class. So for now, negative 144 can we find the square root of a negative number? No. So for now, we're just going to say this is imaginary. The imaginary, yeah. Next class, you're learning it.
And 182.
Yep, all the negatives you can just put imaginary on. Do you want one more example? All right, let's try number 8, 392. On your test where you do not have a calculator, are we going to ask you to simplify a radical of 392? No. It's a little too much, right? It's a little too high. This is hard to think of the factors of. But for now, you can use your calculator to help you out. How are you doing this in your calculator? Like, what should you do to find perfect squares? So I would just keep going up and up and up. So 392 divided by 4, 392 divided by 9, 392 divided by 16, and seeing if it's a whole number.
Oh, 196 and 2.
Oh, that's good. Last class only did 4 and then 16. Let's start off small because you may not have gotten that one. So let's do 4. Let's pull a 4 out. 4 times what is 392? So 4 times 98, you said? What is the square root of 4? Now, does 98 still have factors that are perfect squares? Yeah, it does. What's a perfect square that goes into 98?
49.
Is it? Perfect. So how can we split 98 again? 49 times what? What is the square root of 49? And what is 2 times 7? Now, does 2 have a perfect square that can go into it? No. That's how I know I'm done. I've simplified this as much as I can. You just keep working until you've pulled all the perfect squares out. Or, like we did over here, we figured out that 392, what perfect square can go into that immediately? 196. We could have done 196 and 2. Well, what's the square root of 196? 14. So we could have immediately pulled out the largest perfect square of 196, but sometimes it's hard to figure that out way up top. Okay? Does this make sense? Yes.
Well, one thing that I do whenever I'm like doing radicals like this, like I know we don't have calculators on the test, but I'll take the number and I'll put it into y equals, and I'll say y, I'll like do the number divided by x, and then I go to my graph, or not my graph, my table.
Yes.
And then I go down the table.
Yeah, there's
until
a trick.
Find like the smallest
Yeah.
perfect square that I can.
Yes. I don't want to teach that trick because it's a trick. So shush.
I did that in like 7th grade, and my teacher got mad at me for it. But it's just
Because we're not going to have the calculator on the test, so it's not good to. I mean, it's.
I know. But like,
I know.
You got mad at me for it.
So, what happens here when we have an x with an exponent that is an odd number? You have to leave it inside the square, because when you are square rooting a variable with an exponent and the exponent is even, what do? Divide it in half, because you're literally asking yourself, okay, so what x times itself will be x to the 6th power, right? Well, what do we do when we're multiplying variables with exponents? What do we do to the exponents? We add them. So x to the 3rd power times x to the 3rd power is x to the 6th power, right? So the square root of x to the 6th is x cubed. We cannot do that, however, with exponents that are odd, right? Because what is half of 7? 3.5. We cannot put decimals. So x to the 7th power remains on the inside of your radical. like so. Now, what did 1573 break into? 121 and 13. And what is the square root of 121? So we have 11 square root 13 x to the 7th power. Done. That would be my answer there on number 15. What happened to my drink? Thank you. Okay, so the reason that we had to review this is on the back. So go ahead and turn your paper over. On the back, we are now actually solving quadratics. Now, we can either factor a quadratic and find the solutions from the factor, or sometimes it is easier to do other methods. One of the times that it is easier is when you do not have a b value. Now, which one is our b value? The one with the single x. Good. So we see here in all of these examples, we are missing the single variable. We have an x squared and we have a constant, but we're missing the middle term. Whenever we're missing the middle term, it is easier just to square root. What do you think that means?
To put like a radical around it.
When? Right now? Like would I just square root everything?
No.
No.
You have to subtract the 4 and get the x.
Yes. So you're basically just solving here. What do I do first?
Subtract 4.
Subtract 4 from both sides. So what's 40 minus 4?
X squared.
So now what do I do to get x by itself? You square root both sides. What is the square root of x squared?
X.
And what is the square root of 36? Now, what else times itself equals 36? 6 times 6, what else? Negative 6 times negative 6. So not only do we have a solution of 6, what else do we have a solution of? So the square root of 36 is actually plus or minus 6. We have two solutions here, plus or minus 6. Yes, right. Anytime that you are solving and you are square rooting, you will have two solutions, plus or minus. Okay. So, would you like me to try one more?
Yes.
All right. What do I do first here in number 2?
Subtract 2.
What is 326 minus 2?
324.
And then what do you think? What is 324 divided by 4?
81.
And then what do? And what's the square root of 81?
9.
Not only 9, but plus or minus 9. Do you think you're always going to have nice and neat square roots? No, this is when, if we had come up with a number that wasn't just a boom perfect square, this is when you would have to simplify your radical. All right, you guys try a couple. So to use the quadratic formula, I label my numbers with A, B, and C, and I write my quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And all you have to do from here is fill in the numbers. So what's your b value? It's your variable equals. So what is our b value? -5. So what is -5? +5 plus or minus the square root of, what is -5 squared? Maybe I should show you I'm actually plugging these in, huh? So -5 plus or minus the square root of negative 5 squared minus 4 times a, which what is a? And what is b? I mean c. All over 2 times a. What is our a? And from here, it's just simplifying. So negative negative 5 is the same thing as positive 5, plus or minus 5 squared is what? Negative 4 times 2 times 3 is negative 24. And 2 times 2 is 4. What is 25 minus 24? Can 1 be perfectly square rooted? Yes, it can. What is the square root of 1? So it's 5 plus or minus 1 over 4. What are my two solutions?
5 plus.
Yeah, 5 plus 1 is how much? 6/4, which can be simplified to 3 halves. And then 5 minus 1 is how much?
4 over 4.
And 4 over 4 can be simplified to 1. 5 minus 1. So on this side, I did 5 plus 1 and got 6. Here I have to do 5 minus 1 and I got 4. So these are my two solutions and I'm done. Just like that. Was there very much thinking involved there? It was mainly just simple math. A lot of simple math.
Symbols are always have like really easy simple math, and then like the practice is like subtract 20,000.
Let me do one more. Let me do one more, okay? So example 2. What is different about this one? What do you think I need to do first? Move that 18 over by subtracting it. So now I'm going to use my quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So what is my b? So I put negative 4 plus or minus the square root of negative 4 squared minus 4 times a, which is what? And times c, which is all over 2 times a, which is good. So I have 4 plus or minus negative 4 squared is, and negative 4 times 8 times negative 18. 176, did you say? 576? All over 16. And what is 16 plus 576? What is it?
592.
And what do you think we're going to have to do? We have to simplify this square root. Simplify this radical. What perfect square can go into 592? I know. It takes a lot of room. 4. 4. What 4 times what? 148? 4 doesn't go into 148 as well? Simplifying radicals, right? And you plot a 4, and then you think to yourself, well, 4 also goes in that remainder, right? What is 4 times 4?
16.
So that means that 16 also has to go into that. So the square root of 16 is what? And what was the remainder? 37? This is as simplified as I can make it. Oh, no. One more thing. What goes into 4, 4, and 16? 4. So I pull a 4 out of all of those. 1, 1, 4. And that's it. Do I need to break that down a little more? Did I just blow your brains? Does everyone understand what happened? Those are your solutions. These are your solutions. 1 plus square root of 37 divided by 4 and 1 minus 37 divided by 4. That's as simplified as I can get it. Remember, I told you, use the quadratic formula when it's not a nice and pretty whole number. Is this a nice and pretty whole number?
No.
For sure not. This is why we use the quadratic formula. Because yes, it touches the x-axis, but they're at some crazy decimal points. So instead of just putting some crazy decimal points, we leave it nice and neat in simplest form. Any more questions?